Hello, my name is Monica. I am putting a little disclaimer here because the things, my research was more theoretical, so most of the stuff that I'm going to talk about has not been proven. It's still in the works, and at the end, if you are confused, don't worry, I'm as confused as you. Don't worry. Okay. So, a little introduction to general relativity. General relativity talks about gravity as a curvature of space and time, that basically when there's a mass, like a large mass, or any matter that has mass, curves the space and time around it. And that's what gravity is. It's not a force, it's a consequence of that curvature. And we have things called I don't know how to pronounce that, geodesics. Yes, they are the shortest path to travel in the space-time. It's a straight line, but when there's a curvature, they go through to make that path. And then it uses speed of light as a constant. Nothing is faster than the speed of light, that's what it claims, and it's deterministic because we have cause and effect. We can predict what could happen just by seeing what happened before. And then a little introduction to quantum mechanics. In quantum mechanics, it's a little doozy because it's probabilistic. We don't know anything until we ask the question and we get the answer. That's very confusing. We have things called superposition and quantum entanglement, where particles, they exist in every possibility until they are measured. And when they are measured, they get that superposition and they become that thing, I guess. Yeah. And then entanglement is that you can have a particle, split it in two, it becomes quantumly entangled, and you take one particle and you shoot it to the edge of the universe. And when you calculate the one that you have, if it's a spin up, the other one, information is instantaneously traveled through space. And we know what the other one is, which defies general relativity because it traveled faster than the speed of light. And then we have the uncertainty principle, where we cannot know both a momentum and position of a particle. If we do, then we will be like God. We would know everything that would happen tomorrow. So we have that. And then wave-particle duality is that a particle is a particle and also a wave until we calculate it. And it's probabilistic. We will not know anything until we measure it, and it's dependent. The answer is dependent on what we use to measure it. So, the challenge of unification is scale differences. General relativity talks about large scale, so like the sun, like the planets. And quantum mechanics talks about the smallest particles, like atoms, quarks, really small items. So there's a scale difference. A conceptual difference. How can we combine deterministic and probabilistic, like free will and determinism? How can we combine these? These are the problems that we still do not have the unified field theory. And nothing can go faster than the speed of light. Quantum mechanics says we can, and we actually can prove entanglement and superposition using quantum computers, but relativity, both of these are true things that contradict each other. So there's a problem. And yeah, determinism and probabilistic, how can we combine these? There's an issue. So I came up with a new word. It's called the quantinimity of things. So it's my attempt to combine these two big theories. So I made some claims. So in quantinimity of things, every observable object not only obeys classical, which is general relativity, but also possesses quantum structure within it. Because when you see like daily objects like this, and you split them to the smallest item, they are made out of quantum particles, like particles that exist in the quantum state. And then, another claim is that this quantum structure underpins and influences the physical, which is the general relativity form. So what happens in the quantum state affects the relative state, that the physical that we see here. Okay. So another claim is, I know there's no image here, but everything is right here. All the image that you need is in here. That's a singularity, okay? So there's an image. Everything, actually. So these are some of like an extension of my claims. So everything came from a singularity. We know that's true. We came from a singularity, and that singularity split. And now humans, we have the solar system, we have everything. We have cars, we have taxes. So every observable, and so since we came from a singularity, every single one of us and every single thing on Earth is quantumly entangled with each other. So that's cool. Every observable and non-observable matter has a quantum and relative structure. So when you see me, I'm a human, but I also have quantum structures within me. I have a DNA. I am made of atoms. Those atoms, you can't see them, but they're here and they affect my life. And all. So like that's a claim. So if it's not true, it's not true. Everything can be quantified to a particle, and quantum mechanics can apply to it. So for example, when we talk about quantum structures, we're talking about atoms, quarks, and such. But we can quantify me as one quantum structure. I can be one particle, and then a whole quantum mechanics could apply to me as one person. And then it attempts to solve many universe theory. So many universe theory is like the multiverse theory, that there are different branches out there that is very similar to us, but they have different lives. So the way it attempts to do that is, for example, look at ourselves. We all are made of the same thing, right? We have a head, we have arms, we have legs, but when you look deep, our DNAs are different. In the quantum structure, we are all different, but we are relatively the same, made out of the same thing. So that's how, so like we are all living multi-universes. So even though we're made out of the same thing, I have different versions of my reality, and everyone has different versions of reality. So the observable universe as a particle observed by God. So you can quantify the entire observable universe as one particle. And remember when I was talking about the particles, they exist in multiple states until they're observed and calculated. So the whole universe lives in different states, but since there is an observer, which is God, observing us, we are quantified to this universe. So that's what it claims. So every particle extends quantum fields, and that is what creates interference. I'll get into that. So quantum fields, this is not my claim, this is an actual thing. Every point in space carries a quantum influence that gives rise to particles and interactions. So in space we have quantum fields. They're conceptual, they're not real, like we can't see them, but they extend in space-time, and that's how interactions happen. So I have a little code here that I made to explain that. Let me just try it real quick. It's a little scary. Okay, so when you see this, so these lines, each line is coming from a tangent of the circlet, right here. Is coming straight from a circle. Just observe, and this is 2D, there's nothing 3D here. Just observe what happens when I move it. When I move it, it has an illusion where you see it's a 3D. It looks like it's coming to you, but all I'm doing is I'm moving it to the side. And there's more circles in here. So the theory suggests that every particle has these fields coming out of it that propagates light. Right, let me cross cut here. Let me just X out of here. So those are the main claims. So ultimately, we still don't have the unified field theory. If I had it, I would not be here. I would be getting the Nobel Prize. So God is our unifier. So this verse comes to mind. For in him all things were created, things in heaven and on earth, visible and invisible, whether thrones or powers or rulers or authorities, all things have been created through him and for him. He is before all things, and in him all things hold together. And just a little visualization. This is what a cell looks like. That's what the observable universe looks like. Very similar-ish, very similar. This is what the solar system looks like. That's what atoms look like. Very similar. And then I have a little video. Real quick, I'm sorry. So we can see brain cell and the cosmos and how we look the same. Space, trees, as above, so below. Like we all come from the same thing. God created all of us, and He created us in His image. And everything in space, even though it looks big and it's far, it's within us also. It's within all of us, and we're created of the same thing. And yeah, that's it. Special thanks to God and Dr. Ted Grant and Dr. Sanders for helping me with the code.